In our previous lecture, we talked about probability and the definitions associated with probability. We also looked at calculating basic probabilities for one event. Let's take a look at what happens when we have more than one event or our probabilities get a little bit complex. And this is where we introduce probability theorems. In this lecture, we'll take a look at the first and second basic theorems of probability and how they're applied given probability statistics in a situation. Our first theorem states that probabilities are expressed as a number between 0 and 1. You'll also see this as 0% and 100%. So the probability of A being 0 means there's a certainty that event A is not going to occur. So if this box here is our probability space, then there is no chance that A is going to occur. So, for example, if we know that in our food process we have produced 50 cans of absolutely perfect product, there's no defects, then the probability of picking up a defective can in that case is 0, because we know that those cans are fine, then we're not going to get a defective can. On the other hand, a probability of event A being 1 means that A will occur. So if our event space is here in this box again, then the probability of A completely fills this box. We know for certain that A is going to occur. So if we mess up our canning process and we know all our cans that came out are bad, then the probability of picking a random can that's defective is 1, because we know all of our cans are not working right. So there's something wrong with them, with the seams, with the product inside, whatever, but we know that if we pick up a can, there's going to be something wrong with it. Usually probabilities work over here on the left, where we have our event space defined by this box, and the probability of A is somewhere between 0 and 1. Now if you look at these illustrations, then you know that the probability of A bound by 0 and 1 has to be within this box somewhere. If you calculate a negative probability, that means that something has gone wrong with your calculations. If you calculate a probability greater than 1, that means that our probability space for A right here is exceeding our box. So that also means calculations have gone wrong. So keep that in mind when you're working on probabilities. Theorem 2 states that if the probability of A is the probability of A occurring, then the probability that event A is not occurring, and this is spoken as P not A, is 1 minus the probability of A. Let's take a look at our box here. So this green circle is the probability that A will happen, and our event box of all the possible outcomes is this rectangle. So the probability that A is not going to occur is this white space, and that's 1 minus the probability of A. Sometimes it helps to draw out illustrations like this when you're trying to figure out, will A happen versus will A not happen. Let's take a look at an example using Theorem 1 and 2. We have 35,000 glass jars in our shipment, and we know that 17 of them have defective mold seams. The mold seam runs along the side of the jar right here. It's from the two halves being placed together in the creation process. So we want to figure out what the probability is of picking a jar at random out of that shipment that has a mold seam that is not defective. Alright, so we're given information about the number of defective jars, but we're not given any number of non-defective jars. That's where we use probability theorems 1 and 2. So we know the probability of event A picking a defective jar is 17 over 35,000, and that's about 0.049%. Pretty low. But we want the probability of picking a jar with no defects. And so what we can do is subtract our probability of defective jars from 1. Notice that I am not using percent here. If I was using percent, I would have to subtract the percentage from 100 to get the correct answer. It's perfectly fine to do that. Just make sure that when you're working with percents, you subtract for 100%. When we do our subtraction, we find that the probability of picking a Non-defective jar is about 99.95%. Now we can double check this if we're not sure that we got the exactly right number by taking the number of defective jars and subtracting that from the total number of jars. And that gives us 34,983 jars. We divide that by 35,000 and we get the exact same number. So we know that they're correct. So we have a very high chance of picking a non-defective jar, which is good. We don't want a lot of defective jars in our shipment. Keep in mind, though, that there's only two outcomes for this probability scenario. You have a jar that is defective or it's not defective. Now, you want to be careful if there's more than two outcomes. This doesn't work with defective versus non-defective. You have a choice of one or the other. But let's say you have a choice of picking, for example, cookies with frosting, without frosting, chocolate or no chocolate. There's more than two outcomes there, especially if both the chocolate and non-chocolate cookies have frosting. So you can get some overlap in your events. And the next couple of theorems we'll talk about will cover what to do in those scenarios.